So here I've got a couple of different types of vats. We'll start with the stock Titan 1 vat. Stock Titan 1 vat is really a great design. It's got acrylic at the bottom, it's got a layer of silicone poured inside of here, and then a piece of film on top. Silicone both acts as a really good adhesive, a good way of adhering the film to the acrylic, and also provides a little bit of movement, which means that the surface might deform a bit when under stress, and that deformation would release any suction forces that might occur. The vat is held down and clamped down only on one end, and so as the part lifts, it'll naturally pull this part up. And this will provide a tilting motion, kind of like the tilters that different systems have, but it also creates a flex, right? Because this end is stationary, and this flex then also causes the bottom of the vat to no longer be flat, and this deformation of the bottom of the tank will help release suction forces, and you can get quite a lot of deformation on this. On small parts, you might release in as little as 1 millimeter, and on big parts you could go up to 8, and you'll basically need as much lift as necessary to release the part. And so it's not fixed. These components are not rigid, but they will kind of flex as necessary in order to release the part. And that means that even really sticky resins like, say, 3DM X series will still work in this vat. You'll need bigger lifts, but you can get it to work. Just lift slowly, lift big, and you can get the release to happen. The downside is if you lift too fast, if you are a bit too aggressive with the vat, when the lift occurs, it can pull this up, and after repeated exposures, normally we'd say if the lift forces are too great, you'll end up, say, tearing your object apart, right? Everyone's got failed prints where their object got torn apart. There's also a weakening then of the interface between the silicone and the film that sits on top. And that means the film can pull up, and then people will have trouble. There are ways to reapply the film or whatnot, but your vat will need some repair work or need to be replaced should that happen. And then comes flex vats. I'm going to start with this design here. And flex vats are then conceptually very simple. Instead of adhering the film to something, you don't adhere the film to anything on the printing side. You just let it go through. You adhere the film on the sides, either with tape, as in this case, or with, say, tension screws, as in this case with a Muve3D flex vat, to hold down. You could in theory think that you could put holes in this and drill in and hold this down with tension on the sides. And since you're holding down on the sides, then you have nothing obstructing the bottom. The problem is that this thing does bow, and so if I push down, it will deform. And so in order to prevent the resin from deforming it, you need to put a backing on. You must have a backing. There is no way to tension the vat tight enough that it won't sag some under the weight of resin. And you know that our layers are really thin. They start at like 100 microns and then go down to, say, 10 microns. You will have enough deflection that this middle here might deflect by 0.5 millimeter. In this case, it's not super tight, right? So it deflects by more than 1 millimeter. But even if it were super tight, 0.5 millimeter deflection means that there's a 0.5 millimeter difference between the depth between what's going on in the center versus what's happening on the thickness at the edges. And that's just way too much. And so you have to back it with something. In the case of the Muve3D vat, there is a very thick piece of acrylic at the bottom here. In the case of right, this vat, the bottom of this vat, of course, is acrylic, and so they have to do everything clear. And for this, I need a backing. It doesn't need to be attached to the vat. I laid this down on the printer just like I showed you previously, and then I just sit this on top. And then when I clamp down the corners, everything is fine. All right. Now, there are tricks. When you release from the flex vat, you've got to pull up, and then the amount of kind of flex you'll get from the vat depends on the level of tensioning. The Muve3D flex vat is extremely strongly tensioned. These black tension bars here put a lot of tension on this, and it hardly flexes at all. This is an extremely rigid bottom. This guy on the other hand, because it's hand tensioned, it can lay flat, but it will flex quite a lot. And I think the greater flexing makes it easier to print high surface area parts. For instance, what I'm printing on the printer right now is one of these. This is a mold for a kind of a threaded tube, and this is what I'm printing right now. And they seem to come out okay. I've got some issues with this resin mix, but anyway, that's another story. That's how this works. How would I compare these? When I first started using this vat, one thing that I discovered is this is thin acrylic. There's just film. There's no silicone. This is much thinner than the acrylic on either of these two. This vat here can be extremely, extremely fast. What do you mean fast? It means that the exposure times go down because there's less UV light being blocked. This resin is so fast that I can get background cure artifacts even printing at 90 micron resolution. Usually people don't start getting background cure artifacts on this particular printer until they get down to around, say, 50 microns with the stock vat. But I was getting background cure artifacts with this, and I had to do the fiddling with the black level on the projector, as many other people have done. And then I also use a little bit thicker acrylic, so you'll notice that I'm not actually using this sheet to print it. I have a print right now. I've got a slightly thicker version. The Muve3D vat, on the other hand, is extremely, extremely slow. Now, I am not sure why this vat is so slow. There's a couple of issues. First, since it sits stood up, there are these screws here, plus this vat, plus a very thick piece of acrylic. This vat actually stands up and is a bit further from the projector than the stock vat. That distance is not big enough that it really has any effect on the focus. But for some reason, this vat here is super, super slow. It's like requires 3 times as much exposure or more as the stock vat in order to cure. Plus, because this film doesn't flex very much, you need to be very careful when printing. I would say that this vat is a tank, but it is a very, very slow vat. So slow that I really, other than my initial experiments, I have not used this. This vat was just a bit too much, a bit too slow and too difficult to use. There are a few differences in the way you have to set up the settings for this vat. With the stock vat, you control the lift height and the lift speed, and you need to have as much height as necessary for the vat to, or rather for the part to release off of the vat. So the part has a large surface area and you are using a stickier resin, you may need more lift, right? You may need 8, 9 millimeters of lift. If the part is small and you're using nice resin like 3D MABS that doesn't stick very much, maybe 2 millimeters, 1 millimeter is enough. In the case of the flex vat doesn't have that much range of deflection. So when I push in this film, the maximum deflection is about a couple of millimeters, around 2.5 millimeters for this particular vat. There are variations. This here is 2 mil ETFE film. ETFE is stiffer than FEP, and this is 2 mil. So it's a bit thicker. It doesn't deflect as much as other configurations, and so depending on the exact tensioning and the exact settings, right, this amount could be different. But generally speaking, regardless of the amount of the surface area, to within reason, I tested at like 1200, 3000, and 6000 square millimeters, and found that the amount of deflection was pretty much the same. It was about say 2 millimeters or so for this particular vat. And so you don't adjust the lift distance for this. You always need about the same amount. Your primary control, your only control really, is lift speed. You need to lift more slowly for large surface area parts so you don't get too many release forces, separation forces all at once, and then you can go more quickly with smaller surface area parts. Another thing is that the part here, when it prints in the middle, I did design this vat so that it sits, roughly speaking, most of the printable area, especially on the small build plate or the most in focus area on the large build plate, will be in the center of this vat on a Titan 1. And when we lift here, the forces are kind of distributed all around the edges. And because this vat kind of pulls up, but it doesn't have all these different levels of motion compared to this one, where this vat both tilts and the bottom will become kind of non-square, it'll flex, right? And both of these actions can be quite large. We don't have quite as big of a range of movement here. And I found that the suction forces, if you don't have an air vent, really matter. You might notice that there are kind of wrinkles in some parts, which you may or may not be able to see depending on the angle here. Just in the middle, there's some wrinkles. And that's damage to this vat caused by repeated lifting on the part. I had a bit of overcure, and this is the part that I was printing, and you see that there are holes here, drain holes here, and then there is a channel here. There's a 0.5 millimeter groove here that's designed to be an air channel, so that the void on the inside of here has an air path out these holes and out the sides so that we don't form a vacuum. It came out kind of okay on this part, but on another part I printed same part. I had a bunch of overcure when I was testing different attachment layer settings, and the air channel here filled in and created a vacuum. And the repeated layers of vacuum, the part still printed, but the repeated layers of heavy separation forces, and you could really hear it. The separation was loud when I was printing, caused this strange damage to the vat where there are these wrinkles now built in to the vat. And then there's also kind of a mark left on the edges. Another annoyance kind of with the stock photocentric design is that the stock photocentric design is a non-washable vat, which means they recommend that you simply scrape out all the resin and then wipe it down with a paper towel, but you don't put alcohol or anything in here, because liquids here will get in between the wall and the vat on the underside, and then migrate kind of up the walls, but in particular on the underside. And so you don't want any non-resin to get in here, because whatever you get in here, like you put some alcohol in here, you won't be able to get rid of it completely. And then it'll mix with whatever your next batch is. And so this is fine if you're going to use the same resin over and over again, but if you're swapping resins, you'll never really be able to clean out this vat. Additionally, the resin is going to migrate up the sides. This is just going to happen from the force pushing down on this. And this isn't a showstopper. I mean, what I basically did was when resin migrated up the sides, I hit it with this laser and then cured it, and that pretty much sealed the gap. So I don't have leaks per se, but it's kind of messy. On another version, what I did was I sealed the edges. Let me use a different laser pointer, one that won't cure anything rock solid. But I sealed this edge here all around with silicone sealant, and that's good. If you're impatient, I've also used resin itself. So I used a dropper and put a bead of resin around the edges and then shot it with the laser, and that's good too, and that doesn't require a kind of a 24-hour cure time. You can just kind of seal it and go. So if you're going to make a vat, seal it and go, you're going to change the film, seal it and go, you can do that by using UV resin itself around the edges. That's actually what I have over here on the one that's currently mounted on my printer. When you look at the vat that's currently mounted on my printer, I did seal the internal edges with resin, and so nothing migrated up the sides. Resin will start migrating up the sides during a print pretty quickly. Within less than 30 minutes, probably within the first 15 minutes of printing, I did see resin starting to come up the sides, and I shot it with the laser and sealed it. So it's not super scary. It's not like, oh, it'll look fine, and then 6 hours later, something bad is going to happen. If there's a leak, you'll see it relatively quickly, and then you can take countermeasures, and then you'll be fine. All of these prints, right, this part here, is a 14 to 16 hour print, and I've printed 3 or 4 sets already trying to get the settings right. It is hollow, it's not totally solid, so this isn't like a full bottle of resin on every go. And so long as my attachment layers are good, I haven't had any problem actually getting parts out of the printer. I've just been experimenting settings to get the kind of the hardness the way I want it. So that's it for the vat. Definitely, if you want to put one of these together yourself, you can get someone, say on 3D Hubs, to print one for you. You can you can just buy a sheet of plexiglass and cut it to shape with a saw on the edges, or if you want the kind of the really nice edges in an example like this, right? You can always have one, say, laser cut, order it from Pololu. This is relatively simple. You can order the film easily from CS Hyde or McMaster Carr, or even just off of eBay. I would recommend, actually, I didn't like the 2mm Tefzel that much. I actually have had better results with the 1mm FEP film. And so I would recommend sticking to FEP. I've tried 4mm TPX, I've used 2mm Tefzel, 1mm FEP, and definitely 1 or 2mm FEP seems to be the winner. I haven't done a lot of experiments with TPX. You could try 1 or 2mm TPX, see how it goes. I wouldn't recommend more than 2mm. More than 2mm, and it's hard to fold up around the edges. And so I recommend 1 or 2mm, otherwise you'll have the bend here, the fold here will cause a wrinkle that will extend out from the corners that I don't like. Whereas here you can see that, well, depending on the exposure, maybe you can't see, but you can see that there's a fold here, but then it kind of relatively smooths out as you hit the bottom, so that there are no stretch or fold artifacts on the underside. So you're going to make these. Definitely recommend 1 or 2 mil film. FEP, that's the standard. If you want to try TPX, let me know how it goes.